This question really is about the side-side angle idea in congruent triangles and the fact that that does not guarantee congruency. See, this would potentially be one such triangle that gives you 30 degrees this side and this side, but you could actually bring the side inwards here and create another triangle. And that's what we're looking for, the conditions required to get two such triangles. The work solutions do it very differently to how I did it. I'm just going to talk briefly about their method. It is really nice. I just didn't even begin to think of it like the way they did it. So they first of all argue that x minus 1 has to be less than the minus x squared plus 6x minus 5. The reason being, if it was longer, then this second, I mean, you get one maybe over here, but the second one would end up being sort of over here, and you wouldn't get this 30-degree angle anymore. That's a nice condition. You can then solve the inequality. And then if you think about minus x squared plus 6x minus 5 sine 30, that is this line here. And x minus 1 has to be bigger than that because if it was less than it, then you wouldn't, I mean, that's the shortest distance to this horizontal line. So basically it just can't be less than it. And if it was equal to it, you just get the one triangle. So it's a nice approach, and you can go run with it from there and solve it, and it'll work out absolutely fine. I'm going to share how I did it. It's just an alternative. So I started by saying, right, both sides have to be positive. So x is going to have to be greater than 1. Okay, that doesn't help from the solutions point of view because they're all greater than 1 there, but it's at least a start. And then also minus x squared plus 6x minus 5 is going to have to be greater than 0, which means x squared minus 6x plus 5 is going to have to be less than 0. Let's factorize x minus 5, x minus 1 less than 0. So we get 5 and 1 as our roots. Let's put them in on a graph. 1, 5. Okay, we're getting somewhere. We can see that x has to be between 1 and 5. Again, that doesn't actually rule out any of the solutions necessarily. It doesn't mean the solution is C. All I've done is said that, x has to be between 1 and 5 for the triangle to exist. I've not actually yet talked about whether, there could be two non-congruent triangles. So let's get into that. We've got an angle side pair, and then we've got an angle here and here, and those are going to be two different solutions. So that's what I want to investigate. Let's apply the sine rule. So I've got sine theta, and this can be theta 1, my acute angle, and then theta 2, my obtuse angle, but we'll just call it theta in general, divided by minus x squared plus 6x minus 5. That's going to equal sine 30 over x minus 1. And sine 30 is a half. So then I'm going to get that sine theta is equal to minus x squared minus 6x plus 5. But remember, I factorized it above. It's actually going to be this over 2x minus 1. So I hope I haven't done too much in one go. Like basically this bit here is this bit here in the negative. So I've just brought it as a numerator. I brought the half, made the half so that 2 is actually on the bottom. It's the same thing. And then I can cancel these out. So I've worked out my sine theta in terms of x. Now here's a bit to think about. If we look at the sine graph, to be honest, we just want to look at this part of the sine graph. Then we know we've already got 30 degrees from one of the angles. So I can't have the other angle going beyond 150. And sine 30 is a half, and sine 150 is also a half. So what I'm saying is we require that sine theta is going to be greater than a half, so that I'm in this region here. See, if it was like 0.4, then yeah, okay, I'd get a solution here, but then I get another solution that's beyond 150, and then I wouldn't get two triangles. Quite tricky, I think, and this is the trickiest bit of my method, I've got to say, but it will work out if you hopefully understand that. So sine theta is going to be bigger than a half, but of course it's also going to be less than 1. And now I can therefore sub in. So let's make it 5 minus x over 2. Okay, because I just basically put the minus in. I'm going to times through by 2. Minus 5 from both. And then divide through by minus 1, which actually flips all the signs around. So x is going to be less than 4 but greater than 3. Just swap the whole thing around. And that is a solution, okay? We didn't actually, I mean, we should really, mathematically check that the sides are all positive, which is what I did earlier. We saw that x was between 1 and 5. But now I see that actually to have these two non-congruent triangles, x has to be between 3 and 4. Well, that is also between 1 and 5. So that bit is sorted, but this bit is like we have to have that um, for it to work. So that ends up being our solution. The answer is going to be D.